Welcome to the CEO Coaching International webcast, brought to you by our friends at Ironside, how CEOs can create competitive advantage with AI. As a reminder, all attendees are on mute, but please feel free to ask questions in the chat at any time, and we will try to address it during the Q&A portion of our program. And with that, it is my pleasure to welcome Ironside Director of Data Science, Pam Askar.
Thank you, Aubrey, and thank you all for joining us on this Friday morning. We're going to talk today about creating competitive advantage with AI. We know that many organizations have questions about AI. Is it right for them? Could they get value with it? Is their data even sufficient enough, right? And they're looking for ways to take advantage of AI and get some value from that. So we're going to talk to you today about who we are a little bit, and then give you some examples of real businesses, both big and small, with data clean and not so clean, who are using advanced analytics and AI today and already getting some value from it. And we're going to talk about some of the common challenges that those organizations have to overcome and how data science as a service can leapfrog you over those and get you started much faster. So as Aubrey said, I'm Pam Askar. I'm the Director of Data Science at Ironside. I have been delivering AI solutions across industries with Ironside for about 6 years. And before that, worked in market research, and before that, even provided behavioral analytics. So I've been doing this quite a long time. I'm happy to be joined today by my colleague, Paul Hardy. So Paul, you want to go ahead?
Thank you, Pam. Good morning, everyone. We're thrilled to have you here on this webinar today. My name is Paul Hardy. I run our professional services at Ironside, and I also run our data strategy practice. I've been at Ironside for 2 years and have a career about 25 years of strategic technology consulting. So looking forward to today's discussion. So I'm going to start us off talking about Ironside's mission. I'll tell you a little bit about our firm quickly. This is a very simple mission, but we really like it. We help our clients use data to make better decisions about their business. We've been doing this for 20 years, so we don't need to be more precise than that. We cover, as you will see, about every dimension of data and analytics that has been around for those last 20 years. This will quickly explain who we are at Ironside. As you can see, and I mentioned, we've been doing this for 20+ years, and we provide what we call end-to-end data and analytics value. And this wheel that you see in front of you here represents that end-to-end. If you start in the upper right-hand corner, we provide strategic advice around all dimensions of data and analytics. Oftentimes that advice will lead to not only a strategy, but a roadmap and a solution or set of solutions that ought to be developed. We then have the capability, continuing around that wheel, to design, build, and deploy those solutions. And we create those solutions really in 3 areas that you might be familiar with respect to data and analytics. One is the data science area, which we're going to talk about today: AI, machine learning, advanced analytics, that sort of thing. The second is in what's called business intelligence. It's a more traditional view of sort of enterprise reporting, and today now visualizations that you may be familiar with. And the third is data engineering. Data engineering is the ability to create all of the underlying data assets, things you've heard of: data warehouses, data lakes, marts, you name them, and what's called the ETL that actually gathers your data from different assets and feeds them into those types of aggregated data assets so that the business intelligence and advanced analytics can turn real value out of that data. And lastly, coming around the wheel, you see govern. We want to make sure that any solution that's created is properly governed. And lastly, manage. So we have a managed service, particularly in the BI area, where if you're managing large and legacy business intelligence platforms that might be more of a distraction, we're able to manage those on behalf of our clients. So that's who we are. And so that's enough of a commercial. Let's get started. And we thought we'd start you out with a very simple thought exercise, being fans of Einstein. So we're thinking about 2 companies here, company A, company B, not necessarily very sophisticated or large companies. And they ask the following questions of themselves. Company A says, can we use our data to tell us about who our most valuable customers are? Can analytics help us anticipate equipment failures or damages? And can we optimize schedules and routes to reduce costs, again, using analytics? That's company A. Company B says, look, analytics, big data, we're not a big tech company. We're not going to do that. Or, our data is a mess. Very common refrain. Our data, it's a mess. We can't do anything with it. Or, maybe next year. Look, we're going to do that. We've got to do a bunch of things first, but that's sort of on the roadmap. So here's the thought experiment. 2 years from now, regardless of the fact that those two companies are in the same industry, which company has a higher valuation? Now, of course, you're thinking, wow, what a trite and thought exercise this is, because of course, I hope you're concluding that company A is the one that will have the higher valuation. I think we all believe that will be true. They're going to start on a journey and build greater valuation over the course of those 2 years. So why do we bring this up? Because today's objective is to help you become company A. Even if you feel like today you might be company B, or you've heard some of those comments from within your company, there's no reason that any company today cannot be company A. Okay, so that's our objective for today. So I'm going to hand it off to Pam to get us started.
Yeah, thanks. I like to start these kind of conversations by level setting us on a little bit of terminology. Terms like AI can raise a little bit of anxiety. And I know a lot of executives, a lot of business leaders, they don't necessarily understand the subtle differences between all these different terms, right? Well, the truth is it doesn't really matter. If you ask any two data scientists to define these, they're going to give you different definitions. And if you're going to ask, how does machine learning differ from AI, they're probably going to have different perspectives. And again, it doesn't matter. And I'm going to preemptively apologize for saying AI on one slide and advanced analytics on another, machine learning, and want to let you know that you don't need to be responsible for understanding the difference between those. All of these terms here refer to a step away from traditional analytics. They refer to using advanced statistical methods to get you deeper insight from your data. And so that's really what we're here to talk about. How do you do that? How do you make that step from more traditional BI into advanced analytics and getting deeper insight? So again, preemptively, don't worry about when I throw one word out versus another, okay? So now that we're all level set on that, let's talk about some examples of AI. When you registered for this event about AI, you probably have some idea of what AI is and some examples of it. And maybe you're thinking about big things like self-driving cars, right, and computer vision, and that's not the kind of AI that we're here to talk about. You may also have been thinking about some of the ways that you interact with AI every day, getting some personalized recommendations, getting personalized marketing offers, or in your GPS and getting next best moves and different route options. Well, all of these are great applications of AI. They're very common ones, but they're really just the tip of an iceberg, really, because these are the client-facing ones. These are the ones that people see and get to experience. And the reality is that underneath the surface, behind the scenes, there are a lot of other applications of AI that are driving value for businesses, that help with logistics and operations, that help to optimize decision support. And so Paul's going to walk us through some of those examples, and then we'll get a little bit more specific about it.
Great. Thank you, Pam. So that's what we wanted to talk about, are goals for your business, right? Because these are decision support objectives. So the first question we want to pose is, how do I better accomplish these goals? So a first insight into AI is that you may be doing things extremely well. You've been doing them for years. The question is, how do I do them better? Some things you may not be doing at all and wish you could, but you have to keep that word better in mind. Otherwise, you'll talk yourself out of applying AI to some of your business problems and challenges. So by better here, we mean, how do we do things more accurately? How do we do them more quickly or more efficiently, meaning my resources can produce results a lot faster, and hopefully all of those things at the same time. So what kind of business goals are we talking about that can be addressed by AI? So we've got them grouped here into the three categories we all talk about all the time. We're either trying to grow the top line, reduce cost, or manage risk. And what you see with all these bullet points and bolded words are things that I hope resonate with you in terms of the challenges that you face in these categories every day. These are all problems that AI and machine learning focused on decision support can perform better, more accurately, more quickly, more efficiently. I'm not going to read them all to you. I'll leave this up for a moment for you to recognize them. And then what we're going to do is have Pam walk through some specific instances of some of these questions. And again, I hope these questions all resonate with you. But first, I want to talk about, where does machine learning and AI apply? You might be asking, those are a lot of different instances. And the answer is, actually applies everywhere. Where does it best apply? this is a quote from a McKinsey Global Research study. And I love this quote. It says, companies are finding the greatest benefit from AI comes from applying it where the business already creates the greatest value. This is a really important conclusion to reach. A couple of points. One is, yes, it applies everywhere. We actually have statistics on different functions within an organization where AI applies today. There are market studies that show that. But this conclusion is an important one because often, if you're not keeping that better word in mind, you might believe that, look, we've been doing what we do for 20 years. We're the best at it. Our people are the best at it. That's terrific. That is your special sauce. That's where you're creating great value. That also means two other things. One is that you've probably pulled every lever you can pull to optimize your outcomes around whatever that special sauce is, because you've got the best people and the longest experience. Right. So you've sort of run out of incremental ways to improve what you're doing potentially. The second is, because it's something that you do very well, it's probably a place where you have data, right? It might not be the cleanest data in the world, you think, but it's probably a place relative to other functions you have in your organization where you've got a history of conducting related transactions and you've accumulated data that is aligned with those transactions. That becomes an asset that can help you adopt AI. So think about AI as something that can go anywhere, but don't shy away from applying AI to where you're already the best. The point of AI is it can exceed human experience and human intuition. And sometimes what we do best is the last thing to which we will apply these kinds of tools. So with that, I'll have Pam walk through some examples.
That's a great point, Paul. And so I'm going to talk through 3 clients that we've worked with. And even though you may not necessarily be a foam manufacturing plant like this example, I think you'll be able to relate to the business question that they're asking and appreciate what machine learning was able to do for them there. And also see where those questions that Paul put up, that they are very, they're not industry specific, they're kind of broad and stuff, but here we're taking those down to that secret sauce. We're taking those down to what these companies do, what is their specialty, where do they get the most value, and applying machine learning there to help them out. So this example, like I said, it's a foam manufacturing plant, and they're located in the south where there's a lot of heat and humidity. And that heat and humidity can wreak havoc on their baking process of this foam. And so what ends up happening is these chemists have to go through a trial and error process. They need a certain grade of foam to sell back to their customers. And they'll go through mixing it, baking it, letting it dry, testing it. It's not right, they try it again. And so they came to us and asked, how can we better optimize the machine settings and the chemical recipe given the weather conditions, so we don't have to go through this trial and error. And so we looked at their data, and as I talk a little bit about the data and the machine learning, we'll get into this in a couple of slides. I'll give you a little bit deeper look at that process. But just to think first that, the data they have and the outcomes, right? So they've got all their trial runs, they've got the machine settings, the chemical inputs, their quality logs. They even had some weather data, right? And so we were able to take all of that and build machine learning models and eventually use that to create a simulator that the chemist can then use. Instead of going through that trial and error, they can enter in the grade of foam that they're trying to get, that day's weather conditions, and get a simulation of the optimal machine settings for them, right? What that does is it reduces all that wasted product that they can't sell or have to sell now at a lower quality, at a lower price. Save them a ton of time, because this is a long process to go through this baking at each time and do that trial and error. This resulted in tens of millions in compounded annual savings, right? As well as the increase in the velocity of their supply chain, getting able to move through this and increasing revenue in other ways. So this was a huge win. Also one of my favorite projects because it was just complex and interesting and very fun. Let's take a look at another one. So that one really was about reducing costs, and this is a bit about reducing risk. This is a utility company, and in the past year, some of you may have been in this position, but a lot of people dug up their backyard to put in a swimming pool, right? And before you can do that and put the shovel in the ground, you've got to call 811 and get permission from the utility company so that they can check and make sure that you're not at risk of damaging any of their assets, right? So when you call 811, what happens is a ticket gets logged, and there's some analytics behind the scenes to measure how much risk there is. Now, if it's high risk, right, they want to send their own supervisors to be there on site and manage that and help to reduce the likelihood of damage happening. But they only have so many of those resources. So even though this is ultimately about reducing damage, this is also an optimization problem. We have a limited resource set, and we need to dispatch those where the risk is highest so that they can provide the most value. And so we pulled in their 811 call data about the excavators, their damage logs, even some GIS location data, and applied machine learning to that so that they could at the end have an application to manage those tickets as they come in, to understand the risk and have a risk score for each of those tickets, and have a button to click to say, okay, we're going to dispatch a supervisor to this one, or to automatically do that if it's over a certain threshold. So this was a huge value for them, really helped them to optimize those resources and ultimately reduce some of that damage. Now this next example, this is a really interesting one. This is a relocation management firm, really not that sophisticated in their analytics, but they have a team of people that are moving thousands of people around the world at any given time. So if you want to move any of your employees from Boston to Shanghai or anywhere else, one of the first things you're going to ask is, how much is that going to cost? And how long is that going to take before my employee is working and productive again? Because this is a disruption in their lives, right? You want them productive. So how long and how much? And they actually couldn't really answer those questions. They had a really hard time nailing that down. And so they asked if we could help solve that problem. So we came in, we looked at employee data, right? Because not surprisingly, it's very different to move a single 20-year-old across the world than a 40-year-old with 3 school-age kids, right? A lot more involved there. The vendor data and shipping data, even complaint logs. And we used all this to build a number of machine learning algorithms to forecast expenses, predict how long things were going to take, anticipate anomalies in the move, and delivered back an application to manage this. Now, this was a client-facing application. So this relocation management company was able to supply to their clients this application where they could see the predictions and outcomes of all these things, and they could get those answers. How long do we think it's going to take for any given employee? How much is it going to cost? And how much are our total expenses in relocation this year forecasted to be? Now, what's really interesting about this example is that this got a lot of attention. They did a lot of marketing around this. And there's another firm that also was not very sophisticated in data and analytics, but felt like they might be able to do that. And they see this firm that's in a similar business, smaller than them, that's providing analytics as a service back to their clients, that's monetizing their data and paying attention to this. Shortly after this was released, they were acquired by that firm. And this was the event that caught that interest. So just the ability to monetize data and apply these advanced analytics really can raise the valuation and the interest level in any given company. So let's talk about how this works a little bit. I talked about the different data sources we used and applying ML, and that applying ML piece is very vague and unclear. And I just want to give, again, kind of at a high level, a view of what that process looks like and how does that work. Well, let's take another example, say a cable company. Cable company needs to come out to your house and give you some service, and they give you a 3-hour window of when they're going to be there working on your house. That's not a great window. Nobody likes that. We want something a little bit more precise. And so they want to ask, how can we better predict how long this is going to take so that we can increase customer satisfaction and customer retention? So what we do in this case is we look at data and we start with a problem where we know the answer, right? If they want to know how long does it take to perform any service, they already have the answer to that in their data, right? They can look back in the past and say how long any service has taken. They have service logs when it started, when it ended, right? They also have some related raw data elements. They've got those service logs. They might have data in Excel sheets or Access databases, right? They've got CRMs and data warehouses. So they have all these different raw data. They may even have third-party data. Maybe they hypothesize that weather could be something that interrupts with this process and causes services to take longer or be delayed. And so that's the second step there, is to gather all that related data to your known answer. And then we move on to feature engineering. So this is a really important step. This is in fact the most important critical step of the whole process, and it's the most time consuming. Machine learning step gets all the attention, but really this is the most critical step, is taking that raw data and extracting out of it meaningful features that you can use to relate to and use to predict those outcomes. So
yeah, Pam, what I like
yeah,
to say about this step is this is where the alchemy takes place of AI. If there's great mystery in AI, it's actually here. This is where having well-trained, experienced data scientists matter. How do they take raw data and create data features from that? And I don't know if you want to give an example of what a data feature is versus a raw data element.
yeah. So for example, if this is this cable company and they're trying to predict how long a service takes, they can look back at their historical data and look at any given technician and pull out how many years of experience does that technician have? What's their average efficiency? How fast are they in general? Because then you can look at an upcoming service. Who's the technician that would be deployed? How long do they take? That's one of the many inputs that would be added to the machine learning process, right? And feature engineering, it is so critical. It takes the most amount of time because it's technical and it's working with all that data. But it's so important. It's the one piece of AI that really can't be replaced by AI, right? You've got to have a flexible and creative thinker looking at the data. And more importantly, you actually have to have your subject matter expertise, right? We never build these in isolation. You know your business and you're going to have the best hypotheses, those end users, those people that are working with this data, that are working with the outcomes, that are working with the business results. They're the ones who have the best hypotheses about what data to look for and what features we could extract. And then we can do that feature extraction. So this is, excuse me, this is one of the most critical pieces of the whole process. And then we take all those inputs. We sometimes engineer hundreds of different data points, right? Your final model may only have a dozen or 20 or whatever, but we pull all those and we iterate through this machine learning process. And by the way, again, this is the part that people get a little bit anxious about. It's just math. That's really all it is. It's taking all those data points and trying to find the ones that line up for the outcome you're trying to predict, right? It's trying to find certain patterns. And so what we do in the end of that, we have an algorithm. We have that final algorithm that says, aha, we know the key, we know the pattern that's going to get to that outcome. And so the next step is to validate that. So back at the beginning, when I said you know your results in the past, we take a subset of that and we just hold it aside and we blind it from ourselves. So after we've developed this algorithm, we can say, all right, well, let's test it. Let's see how good this algorithm is. And so we apply it back to that data where we know the results. And we see, can it actually predict what was known? And if we're pretty comfortable that it's doing a good job, that really does seem to understand those data patterns and be able to give us predictions that we're happy with, then we move on to production, right? And so we stop looking behind us and start looking in the future and start applying this to, tomorrow's services that have to happen and making some predictions about how long each one would take and giving some estimates to customers.
Great.
Anything you'd add on that, Paul?
No, I think that was terrific, Pam. Thank you. So, Pam just went through the process and you saw that process applied to real examples. So the question is, what's holding you back? What's holding any organization back? The fact is that penetration of AI in any successful way is below 25% in the marketplace. So, the ship has not sailed yet, but people are starting to, line up at the dock. And so it's worth asking, what is holding back organizations moving forward? So we want to talk for a second here about what are the main bottlenecks. And being data-driven people, we went out and found data, survey data related to this from a company called O'Reilly. And I think if you look at these rationale here, these reasons on the left, it'll make a lot of sense to you. The first one, company culture does not recognize a need for AI. As executives, you recognize the importance of change management in any key initiative that you have in your organization. And you can see here, not surprisingly, that company culture at the core of change management is listed as the greatest bottleneck. Now, our belief is that that's not actually a cause, that's an effect. And it's an effect of some of the other things that you see on that list. A lack of data or data quality issues. We're going to talk a lot about this because this is the one that really holds people back the most in our opinion and our experience in talking with our clients and prospects. Next, you see a lack of skilled people. Not surprisingly, as you heard Pam talk about what we've done, it takes a great amount of skill to do that. You heard her talk about feature engineering where key data scientists are critical. So having a lack of skilled people is clearly a problem, an understandable one. Difficulty identifying use cases. So use cases is, well, all those problems that you saw listed, where do we actually apply AI and ML in our organization, right? That does take some art and some science to find those use cases, and it takes, as Pam mentioned, your subject matter experts to do that right. Then you see technical infrastructure challenges, right? This is tech. There's tech underlying this. We'll talk about that, and people understandably are concerned about the tech, both in creating the AI and deploying the AI, and actually in gathering the data that underlies some of that AI, right? And those aren't the only problems. There's more problems. Maybe you didn't see your favorite problem listed there, right? It's too expensive, right? You hear that a great deal. It takes too long, right? We're going to go on this effort forever, and we're not going to get to results in time. IT says we need to fix our data warehouse first. We're 2 years away. So I mentioned on the left-hand side here, item number 2 there, the lack of data or data quality issues. Now, this is sort of that from another dimension. You as leaders in your organizations may hear your IT people say, oh boy, no way, our data's a mess. We can't do that yet. This is, again, critically important. And we're going to talk about the relevance of this in some detail, because this is holding people back the most, and it's really a misconception. And importantly, I've read that most AI efforts fail. Well, that's true, actually. Industry statistics are that is the case. But we're going to talk about the fact that failure is not always bad, particularly in AI. It's about kind of the agile approach of how do you fail fast, right? Because what you're going to find is that your data isn't always predictive. Pam went through that list, and you turn out an algorithm, and that turns into something you can deploy, but only if there's predictive value in there. So you've got to figure that out early and fast, and that's a good fail. All right, so with that, we're going to turn it over to Pam to talk about some of those problems.
Yeah, we're going to start off with the cost one, right? How do we make this affordable? Well, to go through that process I talked about, there's 2 options. One is that you can build it, right? You can start with building everything that you need to go through that process of data feature engineering and machine learning and deployment. So this is kind of what it looks like. Ironside has helped many organizations go through this whole process. So we know these challenges and these steps very well. You know, there's going to be a lot of vendor selection and POCs with different technology. You can code algorithms in open source, but really to deploy them back into production, to monitor them, to scale up, you're going to need some machine learning technology. You may even need some data wrangling technology to help with that feature engineering and pipeline management. So you're going to have some infrastructure challenges, right? Fitting all that in as well. And of course, at some point, you've got to hire a data scientist. But there's no one data scientist that actually creates a data science team. I really stress on how important a data science team is, because data scientists come from very different backgrounds with different skill sets. And one of the most important other players in that team are the data engineers, the ones that help us put things into production and get it back to the business. So you're going to need some of those. I put experienced designer. Not every use case requires them, but I find them super valuable as well. So they can be part of the data science team. You've got to conduct your pilots along the way, move on to really building out machine learning models, deploying them, getting them into production. So this process, as you see here, is that ramp up, that build, and everything that you need to do. So you're starting to pay, upwards of $800,000 a year just to get things in place, right? Not even to expand the team. You're looking at close to 24 months probably before you have all these steps in place. You've started this process, you've identified use cases, run these pilots, gotten the team in place. In that time, you're paying these costs, right? But you're not getting the value yet. And so you as a leader of the company need to be really bought in that AI is the way to go, that we're going to get value out of AI and that it's right for us, right? To put this kind of investment in. You may not be there yet. Most leaders aren't yet, right? They say, show us first. Let's try a sample. I see it's valuable for that business over there, but what about for me and for my messy data? Is it right for us? And so there's a lease option that we're going to talk about. So this lease option is called data science as a service. You've probably heard the as a service term quite a bit. It really just means leveraging the investment that someone else has put in place, and so that you can pay for consumption, right? And so Ironside has a data science as a service solution we call Ascend AI. And we have had organizations go through this end-to-end process and get value from their AI use cases in as little as 12 weeks with around $200,000. So it's a huge difference. Both of these organizations starting at the very same point saying, what is AI, right? How do we get started, right? In 12 weeks, you're getting value from it. Or in 12 weeks, you're still just working on, running some pilots on different technology and looking for data scientists to hire. So this really can decrease the cost and protect your investment. And I can tell you a little bit more about Ascend AI if you go ahead, Paul. We built Ascend AI purposely to de-risk your investment and to make this valuable for you. AI can be risky and it can be scary, and we've all seen those stats about how often it fails, right? We want you to discover that it's going to fail very early and have those good failures so that you can take care of the reasons they failed. Like maybe the data quality is an issue, but you can go back and do something about that. We want to discover that early. We don't want you to go through this whole process, get something into production, and then discover that you solved the wrong problem, or go all the way through machine learning and discover that the data is not really that great and you're not going to get the accuracy metric that you need. And so we built this in these progressive modules. So I'm going to walk through some of these steps and we'll talk about really how this de-risks your investment. Many organizations, they come in and we start them with use case discovery because they say, I want to use AI, I want to get into this, but it could be applied in finance, it could be applied in real estate, it could be applied in HR or operations, and we're not really sure what the right use cases are. And so Paul's going to talk a little bit about that use case specifically because it is such an important step in getting company culture in place and really setting you off on the right path so that you're solving the right problems. So with that, we're going to catalog and prioritize some use cases for your business. And then we're going to take those that have the highest value and test them out in a rapid viability assessment. So we call this an RVA. The RVA, what it's going to do is check three things. It's going to check, do you have enough data? Is the data clean enough? Not clean. Spoiler alert, nobody has clean data, like really good clean data. But do you have enough? Is it clean enough? And is there statistical signal in there? Is there correlation among these? Do we have some hint that, that there's a relationship there? Because what we want to do is identify this in just the first 2 weeks, right? So again, you can fail quickly, and we have this decision gate here. So you're not, bought into this whole process yet. You're just taking this a step at a time. Let's see if the data is going to work. From there, yeah, go ahead.
Sorry, if I can sort of comment on that RVA step. I mentioned a few times on my earlier slide about the data challenges that are perceived by the organization, including the one that said, oh, it's 2 years, we've got to get our data warehouse in place or cleaned up first. This is a really important step in your understanding of AI and how data science as a service actually works, is that when you focus, if you are use case driven and you're trying to solve a problem, then the only data that you need to evaluate is the data related to that problem. So very important concept, because you will hear from IT, and it's actually valid from their perspective that, wow, our data is really difficult, right? I can tell you that all of the instances in which we have helped clients, there was never a client who had a world of data that was pristine into which a data scientist could dive and poke around and make magic happen. It works in the opposite direction. Find a high value business use case, look for the data that is correlated to it, as you saw in the steps that Pam laid out, and that data only needs to be evaluated for its quality and its quantity and its signal. So, all right, Pam, thanks.
No, that's a great point, because one of the great outcomes from the RVA is if the use case does fail, so to speak, and we don't recommend moving forward with machine learning, you still get a lot of valuable insight. You understand what data would be valuable and what you might need to do to go back and improve that data, either with governance, quality, or you have some gaps, right? And so you get some action items out of that. Now, if it does have the signal we're looking for, we move on to machine learning, and that's that process of training the algorithm, doing all the feature engineering and iterating through that, validating that model. So that when you come out of that decision gate is to say, here's the accuracy that this model got on that holdout validation sample. Make sure we're all comfortable with that and that looks good. From there, we move on to AI implementation. And implementation can be a number of different things. What it really means at a high level is that you're using it in your business, right? It's somehow being used. That could be as simple as a single one-time batch scoring. So we worked with a medical device company, and they wanted to know who are our good customers and who are all the prospect hospitals in the US that look like them, right? So we were able to build that look-like model and score all the prospect hospitals and give them a one-time scoring of similarity so that they knew who to prioritize as prospects. So that's all that was. That was pretty simple and straightforward. This can also be more complex. You could be building an entire real-time application that consumes inputs and has an automated pipeline with it. So this can be very simple or very complex, but the point is that it's somehow implemented into your business. You're making decisions based on it, and it's informing actions. And from there, we have performance monitoring. If we do automate any kind of pipeline and an AI model, we're going to keep an eye on that, right? We want to watch that accuracy because it can change over time. It can get stale. The data can get stale. The market can change. So we're going to look for changes in its accuracy and performance, and we're going to tune it as needed and retrain it. Now, we have organizations that go through this whole step, and we're going to deploy everything and monitor it for them. But by having these modules, it gives you the option to get off the train at any point, right? So again, we're de-risking your investment. And if you look at the number one thing we do there is to give you this this scalable bite-size process. So you're not committing long-term. You're going to try to fail early. You're going to find your data gaps and challenges. You're going to find what use cases are valuable to your business and where there's signal and grow from there, right? So we de-risk it that way. Avoid upfront fixed costs, right? Because again, you're leasing our tech stack, you're leasing our data science team, and I'll talk about that a little on the next slide. We're going to assess that data availability, quality, and signal early. That's what Paul was talking about with failing early in the RVA, so that again, you don't have to go through 2 years of data remediation before you get started. Let's find the relevant data and see if it's good enough. And we're going to be minimally invasive. I don't think this is one that comes to people's mind right away or that they think about. But if you bring in a data science team, either externally or build one, they're going to be working on your infrastructure. You may be doing a cloud migration or warehouse, or you may have data in dispersed systems, and you know, this can be a little bit intrusive. So data science as a service, right? It's on the side. It's not going to be intrusive at all to your current operations. Speed to business value. You're not waiting those 2 years before you're ready to have things implemented and getting value. You're getting it right away. And the sixth one here, I think is the most important, especially for CEOs. The IP remains yours. So we have no interest in black boxing anything here. We want to build AI solutions for you with your data, with your use cases that are customized to the way you operate, right? And all of this IP remains yours. So the code and the special sauce and these algorithms are yours. So it's not about, you know, either black box, we don't own anything or know anything about it, or the build option. You can have both, right? So you can do the lease option and still have all this IP. We even have clients who go through this whole process and they say, okay, now you've got me, now I'm bought in because I've done several use cases. One of them was a big hit. Now it's deployed. We're getting a lot of value out of this. Now we really do want to build this internally, right? We can certainly work with them to do that. Great. So looking at the people and technology issue, this may be a little bit repetitive, or you might have gotten this from the last slide, but just want to talk about what we offer through Ascend AI. So when you've got the skilled resources, I talked about how data science is a team effort. You need the data scientists, the engineers, the solution architects, right? You pay for what you use and not a whole team and yearly salaries. You may not have the infrastructure and technology, but we do. We use cloud data platforms, and we prefer cloud for a couple of reasons. One, it protects your investment, again, because there's no licensing or anything like that. It's pay as you go and consumption. And it also offers the flexibility and scalability that data science work actually requires. It's very iterative, it's exploratory, it'll grow. So you don't know early on how large of a data warehouse you need, for example.
Yeah, and Pam, if I can make a comment there, perhaps we weren't quite clear enough previously, but when Pam mentioned the data science as a service process is non-invasive, that's because what we'll do is ingest your data into a secure cloud platform to do the types of analyses that we described. right? So that cloud data platform is very important for us to ingest your data to do all of those RVA analyses and machine learning models and that sort of thing.
Yeah, great point. Again, we have a number of machine learning technologies that we can use. We do operate tool agnostic, which means that our people have capabilities across a lot of different cutting edge machine learning technologies. Again, we like to use things that are cloud-based and scalable too. We also have third-party data enrichment. So Ironside has some really strong partnerships with data providers, and we actually host some of that data on this platform. And what that does is it allows us to work with you on your use cases. We identify some data gaps, and we've got some third-party data there where it's ready to be used. It's ready to bring in and test and see if that's going to help you. You know, as you hypothesize, well, what about weather? Is that going to impact it? Well, we've got it here. Let's bring it in and start to evaluate it. What about demographics? We have a lot of that there. So we keep that right within Ascend AI. And finally, we have BI platforms. So at the very beginning, when Paul showed you our wheel, we do have a BI team, and we like to deliver back when we deploy these AI models some kind of reporting platform, right? So that you can monitor the performance of your models, you understand its accuracy and any anomalies in it.
Yeah, and yeah, Pam, and before we move on, one additional comment I would make around that third-party data enrichment is back to the issue I keep raising about the question of quality of data. Oftentimes, what we call the boost in signal that you get from bringing in external data is very meaningful to the results that you achieve. You're not expected to have that data internally. We have it in this platform to be able to test it in your use cases and see if it boosts that signal. And of course, you know, that data is already there in quality and ready to go. So,
yeah,
great. All right, so I'm going to pick it up from here. Pam, thank you. So we talked about the culture problem, and you saw on that diagram it was the #1 problem. So how do you solve the culture problem? And there are a couple of ways to do that. The first, you just saw the process that we undertake. And we've mentioned a few times the use of your subject matter experts in that process. And the first place we use them is in use case identification, if that is a relevant part of the process. By the way, we often work with clients who come to us with a burning use case that they have to get evaluated. So that's not at all uncommon. However, we actually prefer this approach, which is to develop a use case catalog. And we do that by working with various subject matter experts in your organization and talking about the functions that they lead and the business challenges that they have. Going back to that list that we brought up to you earlier. We have certain expertise in walking through the business processes that each of those functions control in order to flesh out those use cases. So use cases have to get granular ultimately because they're going to relate to a variety of data that you have in your organization. So our people are expert at working with your subject matter experts to decompose your business and your business processes to find that right answer that you already know. If you go all the way back to the first step in Pam's process as to how does AI work, go back to the cable company, the answer is how long does a service call take today? Aha, that's going to lead us to being able to predict service time better, increase our customer sat, customer retention, right? But you started all the way up perhaps with I want to increase revenue or I want to increase customer satisfaction or customer retention. You keep decomposing and you get down to, well, customers are unhappy because, you know, the cable company gives me a 3-hour window and that really is bothersome. So, you know, we work with you to define what those use cases are. And by engaging your subject matter experts, they're starting to get enrolled in that process. Their questions, their problems are entering the process. And what you see here is a way that we evaluate those use cases. So at the bottom axis, I want to talk about that business viability axis. One of the things we haven't talked about enough, and I'm sure you've been asking, is, well, show me the money, right? How does this work out? Well, we take these business cases, these use cases, and we apply the same rigor that you would apply to any capital investment project you have in your company, right? Oftentimes, this has to be done with what I would call sensitivity analysis in the sense that because this is early on and you have not yet determined how much signal or how much lift you get from a machine learning algorithm, what you can say is, I know if I improve here, it will generate money. And if I improve by this amount to this amount, that's money, that's valuable money. And is it at all realistic for me with machine learning to get into that range? That's kind of a simple way to do it, right? Because again, it may not be totally deterministic to begin with in terms of what lift you will get, but you can start to target a range where you can figure out if the juice is worth the squeeze, right? So we look at that business viability access for use cases, and you see listed there in the fine print dollar value, and then qualitative benefits. There will definitely be qualitative benefits associated with some of these changes that ultimately take place in some of your business processes or applications. We also look at sponsorship. If you're on this call today and you're a leader of your organization, fantastic, because that means the CEO or some very senior executive is going to be the sponsor. Back to change management and culture change, what we know is that sponsorship matters, right? In fact, we've often taken as a first use case something that isn't of the greatest business value, but it's something that has speed and great executive sponsorship so that you can get a proven case of success. And from there, other things become possible. So we evaluate that business viability access, and we simultaneously evaluate data viability. It's not yet to the point of is there signal, but it is for each of the use cases been identified, what is the data? Is there what we call a target, that known question that we have the answer to already, right? Does that exist for the particular use case that's being developed? And what is some of that supporting data? Because at the end of the day, we don't need every piece of data in your organization to be great, because we're going to focus on a very particular question, and we have to know what's supporting that data and whether we can get it or not. Right? So we examine both that data viability and business viability. We actually bring together the subject matter experts after we've arrayed these, and we have them help us plot that business viability. We give them the data that we've developed, but in order for them to get ownership and start to make that cultural change, we work with them to actually plot as a group what that horizontal axis is. And what you see here is a stylized example of what the outcome is. Of course, we're consultants, so we have to have a 2x2 matrix somewhere, and this is our favorite one. So what you see in those little yellow stickies would be an example of particular use cases that get plotted on that data viability and business viability curve. And you can see these 4 quadrants, right? Not surprisingly, upper right-hand side, hey, great business value, great data viability, let's go after those, right? On the left, you see value traps. These are very interesting to us because we think this is kind of the state of the industry today. And this is a case where data science as a service is very productive. Value traps are the case where larger organizations in particular who might have a big budget and are excited about data science hire a bunch of data scientists. The data scientists start going through the data to figure out what they might be able to figure out from the data. And again, that's the wrong approach. Pick the business case first. They may find data that's clean and wonderful and they start digging into it, but guess what? The business viability isn't there. And in fact, often we find that they have a difficult time identifying those use cases because data scientists by themselves, as Pam mentioned, are very varied, and some are great at the math, but they're not business people at their core, and identifying the use cases is somewhat difficult. Those are value traps. Lower right-hand corner, very interesting, data remediation. You may find high value cases, and back to this notion of, oh, our data is a mess. Yeah, maybe you find some things that are high value and your data doesn't work, but at least you know what they are, and you can plot certain data remediation, not for your whole organization, not for your whole data warehouse, but for those use cases that are of high value that will produce an ROI if you do some data remediation. That remediation might be covering it with third-party data, we talked about earlier, what we call data enrichment. It might be, hey, we need a survey. We work, the medical device manufacturer we mentioned, we actually sent out a survey to the sales force and we were able to develop a great deal of fresh data that didn't exist before. So different steps you can take for data remediation. So that's how we create these use case plots. And this is kind of the outcomes. We develop use cases and benefit models, right? You've got to create that economic value for any one of these target use cases. The reason we want to develop a bunch of these is back to that fail fast mode. So you might start doing it and discover, guess what? Our data doesn't have signal, right? It's not going to create anything predictive for us, right? Well, we want to de-risk the all or nothing pilot. What does that mean? It means if everyone was focused on one use case and only one use case was identified and it didn't have signal, culturally, you could see the organization throw up their hands and say, oh, you see, this data science thing was nothing. So anyway, and as I mentioned, we engage the key business and technical stakeholders in the process. We develop what that target profile is. What is that question that we already know the answer to? And at the end, we're able to prioritize these using this framework and move only the ones that matter onto that signal assessment or RVA that Pam described. And again, in that process, we're developing stakeholder ownership. So we're just here coming to the end, right in the nick of time. So we want to confirm here that we think data science as a service solves some of those key issues that we discussed and that we hope that you can overcome. So we already saw these. So let's talk about each of these in turn. First, it's too expensive. It is. It's an expensive process if you build it from scratch, and particularly if you don't know the value of the outcomes you're going to get when you start making that investment. And recognize that if you don't spend a lot, that IP and still come out with a result, that IP is yours. So it's not a lost investment. You know, you've actually spent a little and gotten a lot, and that IP becomes yours. It takes too long. I think we've shown that if you use data science as a service, that's not the case, simply because our platform and our people are in place, right? It is a lengthy process to identify and acquire the people and the technology, but don't do it until you know there's value. You know, I've read that most AI efforts fail. That's true, and they fail because of those value traps that we talked about in that 2x2 matrix, right? Those are bad instances of failing. They fail because of, you know, the same reasons other IT projects do, and that is the project management of putting together that end-to-end process when you build it yourself is often a challenge, particularly if you don't know AI. But we also learned that failing fast is really good if you're failing the right way. The right way is, hey, does my data for that question have signal? If not, cut off the investment, move on, okay? So lack of skilled people, we talked about that, data science as a service. You know, it's hard to get those people together. Believe me, we of course are out hiring these people still for our firm. It's very hard to do, but we're good at it, and we have a great staff of those folks accumulated already. Difficulty identifying use cases. This is critically important. Totally understandable that it's difficult to identify use cases. I talked about our business decomposition from objectives and KPIs down into business processes and the underlying more granular data that affect those processes that become part of your AI model. Technical infrastructure challenges, true, there is a lot of technology. This is a big tech effort. Again, you can, through data science as a service, use that platform and make purchase decisions only if and when you need to later. And lack of data quality and this quote that I've attributed to your IT manager, we talked a lot about that. That's extremely important. If there's nothing else you take away from this, you know, let it be two things. One is, hey, I can apply this to very particular problems and start to get value today. I can do that because I don't need to have a pristine data infrastructure. I just have to have some of the data elements that relate to that key question. And by the way, I can also bring in some extra data that can also apply to that key question, okay? So that's our conclusion. We hope that you like data science as a service. Oh, and I'm sorry, lastly, company culture, of course. I mentioned earlier on that we think that's an effect, not a cause. So we think if you create a successful outcome, the company culture will start to change. It's perfectly understandable that if you don't have good data quality, if you don't have people with skills in data science, if you have difficulty identifying a use case, there's no reason you should expect that your culture is ready to adopt AI, right? But through data science as a service, creating some wins, that culture will start to change. So with that, we want to just end with one real world example, and I'll let Pam jump into that.
Thanks, Paul. And I also want to remind you that we'll try to save a couple minutes here at the end for questions. So you can go ahead and type any questions you have in the chat box. And while you do that, let me tell you about this. This is one of our clients, not particularly sophisticated when it comes to data and analytics, but really approached us saying, you know, is it right for us? How would I get started? What is it? It's a North American hair salon. It's franchised, and they have about 1,800 stores nationwide. So a lot of data, a lot to work on. We started with them with the use case discovery because, again, they wanted to get involved in AI but didn't know where to start. We interviewed stakeholders from operations, HR, real estate, finance, really across the board, and we identified use cases like how can we better predict how long a haircut's going to take or how long the wait time is until they get started, because that'll help drive customer satisfaction. Turns out the most important thing to customer satisfaction is an accurate wait time, not even a short wait time, although that's close behind. Stylist turnover, site selection, demand forecast, all those kind of use cases we prioritized in that matrix like Paul showed. 4 of those moved on to rapid viability assessments, right? So we looked at the quality of the data specific to that use case. We looked at the correlation analysis there. Of those 4, 3 have gone on to machine learning, and we've built and trained and validated 3 different machine learning models with them. In AI implementation, their most important use case that was number 1 all the way back in the use case discovery session was that wait time accuracy. How can we provide a better wait time estimate when they go log in and they see on this, they look at all the stores and they say, oh, there's a 30-minute wait time over here and a 15-minute wait time here. We want that to be accurate. And so we've ended up deploying an application that's a real-time, high-volume application. It's fed by 2 different machine learning models, and that's been deployed and released. And so right now they're looking at the benefits of that, and so they're in that performance monitoring phase. We've also developed this dashboard for them so that their operations team can look at their wait time and break it down by time of day in different stores, things like that, and also look at the variance and the accuracy of the models. And so what they've gotten at the end here is higher customer satisfaction because they're delivering more accurate wait times. And that leads to better customer retention and increased revenue. And also that side effect there of having competitors, other companies understand that this is an organization that appreciates their data, that monetizes their data, that's delivering analytics, and they're delivering it back to their franchise owners. So it's important that franchise owners are getting benefit from this, and it's helping them do their job better, provide better wait time estimates and anticipate demand, et cetera. And so that helps the overall organization be more profitable and raise revenue as well.
So Pam, this is definitely a client that went from the case of company A to company B all the way back, or from company B, sorry, to company A all the way back in our thought exercise. So
exactly. And it really started with literally saying, we don't understand AI. What is it? What could it do for us? And so we'd love to take some questions now while you're typing those up. And I think Debbie has a quick message as well.
Yes, thanks, Pam. I wanted to share with everyone that we will be sending the recording link of today's session, How CEOs Can Create Competitive Advantage with AI, to everyone who registered. We will also share it on the CEO Coaching International website, and you can find it on ironsidegroup.com/resources. There is a data science tab at the bottom of that page, and it has a number of different relevant webinars that we have done, as well as this one, and ebooks. And with that, we do have a couple of questions. I know that we're running to the top of the hour, so I'm going to try to compress 2 of them in one. The first is, how often do you find the data isn't good enough? And can you also make some comments on third-party data and how you found it to be valuable?
Yeah, that's great. And those do kind of go hand in hand. I would say, even though there are big statistics, like most of the time AI fails, that's due to a lot of different reasons. But going through this process, I'd say it's really only like 25% of the time that we discover in an RVA, the data is not really right for this. But what we can do at that point is identify the gaps and the reasons. And sometimes it is data quality, but most of the time there's gaps that can be filled. There's something that can be used to enhance it. And that's where we would always look to third-party data. Can we get some demographic data? Can we bring in external data that will help us understand who your customers are and what's driving their behaviors with you? Because your data might be very transactional and just miss that element. So we'll definitely look for data at that point. But yeah, I'd say it's a small percentage that fail for that. Once it goes on, that percentage gets less and less. And in reality, with the build phase, I think Paul alluded to this, it fails much more often at that deployment phase because so many organizations will build different models, but that deployment and implementation, that is a very tricky task to do. And so a lot of them just don't get through that.
Terrific. And we do have one last question, but I want to also remind everybody, if you do just email us at helloai@ironsidegroup.com, we'll be happy to answer any other questions that might come to you. We may have another one coming in too. Regardless of industry, are there functional areas, Pam, which you have found more beneficial of AI, or that can benefit from AI the most, or specific use cases?
I think, Paul put up there that list of questions. These are ones that come up very, very frequently, but they often still boil down to very specific problems that your organization is facing. So even client churn and client retention for that hair salon came down to something very specific, like we've discovered that the key to client retention and keeping clients happy is accuracy and wait times, right? And so sometimes those use cases like client retention are pretty generic and can go across industries, but boil down into something very specific for you and for your business and the way that you operate.
Thank you. Another question. How can I sell the value of AI or data science as a service in layman terms to my team when AI is, at least to me, still sort of elusive?
Yeah.
Do you have ideas?
Yeah, it is very elusive, and we've encountered that time after time. The use case discovery session that Paul goes through, I think, has been so powerful in educating business leaders about the value of AI and what it really is, and also getting them to appreciate it and take some ownership over their use cases that they want involved. We always start that session with a big educational session to business leaders about what AI is and some of these business examples, and walk them through the steps of use case discovery as well. And so coming out of that, they have a much better sense of it. And then through those interviews, we're talking to them and we're talking about their business problems in the finance team or in the operations team, and giving them examples back through one-on-one conversations about how we might be able to tackle that with machine learning. So it's really just conversations. You don't need to get to the data and analytics part yet, but we find that coming out of that session, really a sense of ownership and drive, and saying, okay, I want that over here in my group. I don't know, Paul, if you'd have anything to add to that.
Well, I think that's exactly right. And prior to that session, if you're just going home and want to talk to folks about it, again, the most important thing is to say that, look, we have a way to do this and determine if there's value there, quickly, and limit our investment if we don't, right? It's about de-risking how we look at AI. If they have concerns because they think it's risky either to capital or to operations or something, hey, there's a way to do it that you can get the answer, quickly and inexpensively. So, and beyond that, it's a typical, what are your pain points of what you're doing today? What do you wish you could predict? If I only knew this better in my business process or my function, man, it would really, save a lot of consternation, cost, or increase revenue, right? Or de-risk something. So,
yeah,
these all trace back to just typical problems that we wish we could all do better.
And on that note, we would really love to have those conversations with you and hear about what are those goals and questions that you're asking for your business, and talk a little bit more specifically about what data science as a service could do for you. Yeah, and if that's all the questions, Debbie, then we just want to thank everybody for their time and attention today, and hope you have a fantastic weekend, and hope to have some follow-up conversations with you anytime.
Thank you all.